Okay, when graphing quadratics, the thing is, you want to put your equation in vertex form. Now, you can't have a leading coefficient when that happens. So, the approach that I'm going to teach you today is I'm going to teach you how to factor out a fraction. If you take 1/3 divided by 1/3, you'll get a positive x squared, which is exactly what you need. If you divide out 1/3 here, you just get the numerator 2x. And what happens is, this completing the square process needs to take place. For those of you who don't know how to complete the square, you need to watch one of my other videos. You're going to cut this value in half and then square it and add it to both sides. However, when you add something to both sides, you have to add the exact same quantity. Some people would say put +1 on the other side, but in this example, what you're really putting is a -3 times 1, because it's distributive property. You see that? And so you should be adding 1/3 to this side, since they got multiplied together. So now you have this equation, y plus 1/3 equals 1/3 times, since we completed the square, x plus 1 squared. I get this by factoring this down to a perfect square. And now you minus 1/3 to both sides. So we just shove it in the back right there. Okay, so now we have an equation. Because we have an equation in vertex form, it's very easy to find the vertex. This x value is by your h. This k value is in the back. That's how you find the center. Therefore, our vertex is at -1 and -1/3. To graph that, you're going to have to do a bit of estimation. Well, here's -1, and 1/3 of the way down is about -1/3. Okay. Now, we found the vertex. Let's actually graph the quadratic. Inputs and outputs. Pick a value that's really close to this input. So we had -1. Let's use 0. So let's find out when we input 0. We got 1/3 times 0 plus 1 squared minus 1/3. Very convenient because 0 plus 1 is 1. Square that. So we really just have 1/3 minus 1/3, which is 0. So when you use 0, you get 0. There's a very easy, convenient coordinate. Let's use another point. How about we use -2, because that's on the other side of -1. 1/3 times -2 plus 1 squared minus 1/3. Also very convenient, because when you do this, you are going to get -1 squared. And -1 squared turns to +1. That just gets multiplied by 1/3. And you get 0 again. This is not a coincidence. These are supposed to be the exact same values. So when you're doing this, you check that your work's correct. Alright, now, we got this parabola, this U-shaped graph. Okay. Now, the focus is a point that's inside this region. Now, if your quadratic was ever turned this way, well, then your focus would still be inside and it would be on this side. Or, let's say your quadratic was facing this way, your focus is in here. Or your quadratic's upside down, well, your focus would be down here. So, depending on how the equation's set up, you're always going to need to know where the focus needs to be. I kind of look at it as it's inside the cup. So, what you do is you need a formula. Okay? So, the formula you need to use is A equals 1 over 4P. Lots of teachers call it 4C, lots of teachers call it all sorts of things. They might not use A. It doesn't really matter. What matters is you know where A comes from. A comes from this number that's in front of the equation, the 1/3. So, this 1 over 4P, that's basically, the focus is derived from a distance, so you'd be using the distance formula. I'm not going to show you that, just you have to trust me that it's over this. So, you get 1/3 equals 1 over 4P, considering A is 1/3. You solve for P. You say, alright, let's multiply both sides of the equation by 4p over 3 equals 1. Then to get p by itself, you divide the equation by 3/4. Okay, so it's called by multiplying by the reciprocal. So you could multiply this by 3. 4p equals 3, therefore p equals 3/4, like I said. Now, this p value is not an input, it's not an output, it's not a point. When you're trying to find the focus, what you're going to do is you're going to take your vertex. In this equation, our vertex was 1 and -1/3. Okay, that was our vertex. And what you're going to do is you're going to add p to it. This will give you the focus. Now, when you're adding p, the thing is, you know for a fact that p happens to be the value 3/4. So you're adding technically 3/4 to this equation. But where? Do you add it to the x? Do you add it to the y? That changes every single time, and it's based on this picture. Because your vertex is what guides your focus. So if you need to add p to your vertex, there's only two directions it can go, either up or right. If you subtract p, it'll go down or to the left. Now in our equation, we want to add p up, because as I was saying, a focus is a point inside the parabola. So the y value is what's the vertical value. So instead of adding 3/4 to -1, we're going to add 3/4 to -1/3. We could do some simple arithmetic. We'll say -1/3 plus 3/4. Add these two fractions together by getting common denominator. So you got -4/12 plus 9/12, which gives you the coordinate 5/12. So at -1 and 5/12, so here's -1, 5/12 is almost about halfway. You'd be able to make a point, and that's your focus. Focus should always be lined with your vertex, and in this case, right above it, because that's what the shape said.